All right, good morning, everyone. Am I audible?
Good morning, sir.
Am I audible?
Yes, sir.
Yes, sir.
All right, thank you. All right, today we'll be having a short class. We won't take much time. And before that, I believe I have received a few portfolios so far. And it's just a reminder that you have the day, as in up till midnight, to submit your graphics portfolio. All right. And any submission later than 12 will come with penalty. So there will be deduction in marks, and that will be dependent on your time of submission. Okay. And whatever you submitted, please try to follow the code that we have mentioned. Basically, the in naming the name of your file. So if you are still unsure, you can talk to your friends as well, and you can ask them the correct format in such a way that none of us are none of you are getting deducted based on your submission style. All right, I hope my screen is visible to all.
Yes, sir.
All right, thank you. All right, today we will be going through stone masonry. So masonry is nothing but your walls, okay? Your walls in the sense your uh, walls in your building, your load-bearing wall, your non-load-bearing wall, and your compound walls as well. All right, so when we talk about masonry, we must think of compound walls, retaining walls, your construction walls, which are basically your the walls that encompasses your building. So in a stone masonry, we have different types, and we are going to go through that as well. It's a type of building masonry construction that uses stones and mortar, as simple as that. So it has many similarities to brick masonry that we studied before. The only thing is that as stones can come in many shape and sizes, depending on the types and the sizes of stones you are using, then you would be given certain names, the masonry that you are doing. This construction technique is used for building foundations, floors, retaining walls, arches, walls, and columns. Yes, sometimes we use stone columns as well, especially in places where there are, uh, columns with high materials, stone materials with high density, like say granite. Then that is a place where you can use stone masonry for columns. And however, in places like earthquake prone zone, you would not commonly find those. But in areas where earthquake is not very frequent, or in let's say in a lesser earthquake prone zone, in such areas you would find masonry columns as well. Not only stone, but also brickworks as well. The stones used for masonry construction are natural rocks. These natural rocks are cut and dressed in proper shape in order to use it in masonry construction. As I have mentioned, as stones, they generally do not have a definitive shape. They are molded, they are dressed in such a way that they are usable, they are workable, and more importantly, they are bonded to each other in a very uh, properly cured manner. Stones are one of the most durable and strong building materials. This is dependent on the type of stone that you would be using. For example, the properties of a sandstone versus a limestone would be different. And as such, the types of usage that it can carry on is going to be different as well. So in places like Mizoram, you would not find stoneworks in very extensive, especially in buildings. You would mostly you would mostly mm, you would mostly see stoneworks in retaining walls. So you are going to more or less relate stoneworks to, especially the local students may relate stoneworks to the form of to the likes of um, retaining walls, like the image that we are seeing over here. It retains partly and it acts like it acts like a plinth to that particular building as well. So you may find up till that level. And nowadays you would often find stoneworks or false stoneworks on buildings like claddings. So mostly these stones are cut and chiseled and dressed to be used as claddings. So when you see these stone claddings, they do not really act as a load-bearing structures. However, they are simply uh, used in non-load-bearing manner, and they are used for decorative purpose only. The stones used for masonry construction must be hard, tough, and free from cracks, sand holes, and cavities. So these are the basic criteria of approaching a stone masonry, and we require a hard stone, tough and free from cracks, mainly because we want it to have a good structural integrity. Okay, and if you can make sure that no such deformation or cracks or holes are there, then uh, it would be deemed fit for a masonry construction. The selection of stone for particular work is dependent on the availability of the stone and the importance of the structure. And the importance of the structure is one thing that is always the key factor, mainly because nowadays in modern construction, if we are to go for a heavy loaded structure, then we seldom use uh, stone masonry, even though it is one of the strongest naturally available material. We have synthesized material, right? We have the likes of reinforcement cement concrete, or we can even further go for steel construction as well. So in such cases, for structural purposes, we will not go for stone masonry. However, even in modern construction, also stone masonry still has room in terms of aesthetics, as it provides its own sense of visualization. So you would often see stone masonry or the likes of it in aesthetics purpose. And it also is dependent on the availability of the stone. So for example, uh, if you are in the central part of India, or especially the western part, Kota stone slab is something which you would find it affordable because they are easily available, especially if you are in the area near Kota. So, however, if you are to, if you are to mimic that, if you are to copy that and make it affordable, or make it uh, applied in as many construction as possible in the likes of Mizoram or other part of northeastern India, wherein the Kota stone slab, or at least the like of it, is not very much in abundance, then it is not going to make much sense, and it will eventually, rise up the cost of construction eventually. However, in places like in places like Mizoram or other areas wherein we don't have much of a hard stone, so we would simply go for the likes of um, uh, tiled constructions, which are basically made up of cement or other tiles, ceramic tiles that are manufactured somewhere nearby. So that is why the availability of stone is always important, and the types of stone that you can see. is going to determine its application. The common stones used for masonry construction are limestone, sandstone, granite, marble, laterite, etc. So, especially for the likes of granite and marble, especially here in this part, they are considered high class, high class stones. Especially not just here, but here it is even further more exquisite. So you often find its application mainly on the likes of countertops and floorings. Types of stone masonry, we are going to go through this. We have rubble masonry, coarse, uncoarse, random, dry, polygonal, and flint. And in ashlar masonry also, we are going to see different types of ashlar masonry as well. Now coming to the first type, coarse rubble masonry. In coarse rubble masonry construction, the stones in a particular course are in equal heights. So when it is coursed, meaning that we are going to have, remember in brick masonry, when we were talking about stretcher course, header course, one course is basically one layer of brickwork, right? But when it comes to a rubble masonry, it is such that one course can be a multiple layer of stones as well. But it's just that that particular course is made up of multiple layer of stones, and they work as one monolithic course. The stones hence used possess different sizes. In this type, all the courses do not have same height, meaning that one course can be higher in height, the other course can be lower in height, but mainly most of the time you want the lower part of that masonry to have a larger or a higher or a taller course. This type is commonly employed in the construction of public buildings, abutments, residential buildings, and piers of ordinary bridges. So here we have an elevation, a plan, and a section. And the thing is, the thing with coarse rubble masonry is that its construction is tedious and its aesthetic is not too pleasing compared to the other courses or the other type of masonry we are going to see. So that is why we do not see this type of construction very prominent or very frequent in nowadays. So uh, in order to mimic some kind of in order to make the likes of a brickwork, we can have a regular, we can have other types of masonry like ashlar masonry, which we are going to talk about. So because of its construction technique requirement, as well as because of its tediousness in terms of its construction, we do not find this type of masonry very frequently. We have uncoarse rubber masonry, and uncoarse rubber masonry has two types as well. So we are going to see that as well. An uncoarse rubble masonry is the cheapest and roughest form of stone masonry construction. These constructions use stones of varied shape and size. And before we proceed on, when it comes to stone masonry, the first thing that I was saying was that stone comes in different shapes and sizes, right? Even though there are hard stones and stones like limestones which are easier to mold, there are other types of stones which are not too easy to mold, and that is why they do not come with definitive shapes and sizes. So, and as such, even in these different types of masonry we are going to talk about, there can be variations, multiple variations. All right. So more or less, for example, in brickworks, as we have definitive shapes in bricks, we can have definitive bones like uh, English bone, Fletcher bone, etc. So, however, in stone masonry, as our stones do not have definitive shape and sizes, they are going to vary in. Uh, they are going to have minor variations even in the same name, and even the different names we give are also going to look very similar. It's just that minor techniques and minor the similarities which make them different. So even in uncourseable masonry also, they are going to you have number one, you are going to have a random uncourseable masonry, which is going to be uh, which is going to be a series of random stones that are laid. So here you can see, especially on the image on the right hand side, you can see that at least the shapes in terms of its height are being tried to keep some kind of regularity. But random and coarse rubble masonry can be a series of random stones that are being joined together with the help of mortars, right? So this one is a random uncoarse rubble masonry. There can be another one which can be uncoarse rubble masonry as well, wherein it would mimic something a little bit like this on the drawing on the left. So however, even in this, it is always safer to have an edge which is a bit like it is saying here, the weak corners and edges of the stone are removed with the help of a mason's hammer. And the queens, so the queens is this part. So the queens is the edge. On the edge, you have a regularly coursed stone, which which is like the backbone of your masonry. Bigger stones are employed in order to increase the strength of the masonry, because as I had mentioned in brick masonry also, the corner is where there would be movement, crack, and crumble at the time of physical shock, for example, earthquake. And when we do a stone masonry, there are the different names are given to the stones that we use. So the facing stone or the face stones are the stones which forms the elevation. So if you have a selective or if you have a curative approach, then you can have a rather random rubble masonry steel. But you can have a backstone or a backing stone, which would be, if this side, if you have a facing stone, then there will be a backing stone on the other side, and the backing stone can be as random as uh, as you can get. So there is this bond stone or bonding stone, or in other term, there will be through stone as well, through, through stone or bonding stone. They are the stones, as the name through stone suggests, that goes from the inner side to the uh, outer side as well. So what it does is it actually holds the whole masonry together. So when you have a good bone stone or when you have a good through stone that actually spans across your masonry, then that is going to act as a clip that holds together your masonry. So you have hearting stone, as the name suggests, it forms the heart or the central part of your masonry, and they are basically acting as the core part, and their function is to form a connection between the facing stone and the baking stone as well. We have a square uncoarse rubble masonry. So it is uncoarse in the sense that there is no coarse wise per se, and you can see that the elevation is very much resembling a brick masonry, right? The stones are made roughly square shape and used in construction. The facing stones are provided a hammer dressed finish. Larger stones are used as queens. Chips are not used as bedding. So here you can see that more or less, you have a regularly shaped rubble masonry. All right. So, however, uh, if we go to the coarse masonry, here in coarse rubble masonry, we have certain courses here, right? Certain courses, one course running, another course running. In uncourse, we simply lay stones on top of each other, and in square uncourse rubble masonry, we make it more formal than the random uncoarse rubble masonry by making it squared and making the joints or the masonry connected to each other. All right, so the connection or the bonds that the masonry is holding, sorry, the mortar is holding is a lot more formal. So you would often find this kind of square and coarse rubble masonry in the retaining walls here in Mizoram, you would often find this the most. And we have polygonal rubble masonry. So polygonal in the sense that the shapes are no longer squarish, and there are the stones for masonry are roughly shaped into irregular polygons. The stones are then arranged in such a way that it avoids vertical joints in the face work. Use of stone chips to support the stones. So here we have polygonal rubble masonry. From the photos, you can see that even in the polygonal rubble masonry also, that you would often find on this particular wall, there is mm, the pattern. If you compare the two patterns, then you would find that on this wall, it kind of mimics the regularity you would often find in the other masonry. But the idea of this is that, as I had mentioned in this, here you would see that the mortar, the joints, it's like it's acting up together and form a masonry, to form to hold the masonry, right? So in polygonal rubble masonry, so you would not find a very well patterned vertical vertical joints in the face work. Okay, not that that is bad or that is good. It is just trying to form a specific, some kind of a specific uh, facade. Facade means the face. The face of this masonry is going to look entirely different. And because of the lack of that vertical joint, it would not tear apart vertically. All right, that is another thing. It would not easily tear apart vertically. Oftentimes in stone masonry and even in brick masonry also, the reason why we always interlock our bones, the reason why we always interlock our bricks with, and here you can also see that the vertical joint is broken, right? It's broken in every course over here. So however, more or less, if you were to tear this apart, it would somehow tear along this line, right? And that is the very reason why we always have a course like this even in brick masonry. So if you look at these polygonal rubble masonry, so you would not easily find one straight line or can form it. So, and especially we are going to learn another one, which is a dry rubble masonry, which is a rubble masonry construction performed without the use of mortar. So you can even go for a polygonal rubble masonry if you have a good selection of stones and not use mortar as well. However, because of the load that may be impacted upon it, whenever you see dry rubble masonry, you tend to have it see it as a tapered um, uh, it, tapered masonry. So if you look at this, tapered means the base is larger than the upper part. These are rubble masonry construction performed without the use of mortar. Small spaces are filled with smaller stone pieces. It is used in pitching the earthen dams and the canal slopes. So you would often find this in areas where you find good amount of stones, not just stones but good quality stones. So here in this particular image also, as you can see, so these stones are laid flat and laid flat in such a way that when the load is exerted upon it also, then there is no you are eliminating the possibility of one piece of stone uh, tumbling down, all right, or falling down in such a way that you want your stone to lay as flat as possible. So often find you would find that the ratio of your wall is always the ratio of your stone is always on the flat side, meaning that the height is always lower compared to the width and the length. We have flint rubble masonry as well. So in areas where flint is available in plenty, a flint rubble masonry is employed. So these are flints. So basically they are They flints are irregularly shaped nodules of silica. They are extremely hard but brittle in nature. So glass is also extremely hard, but they are brittle in nature. So that is the kind of property that flints are also acquiring. The thickness of the flintstones vary from 8 to 15 centimeter. Their length varies from 15 to 30 centimeter. So even if you have plentiful amount of flints, then oftentimes when you stack them up together because of their irregularities, you may find them a little bit chaotic. So in order to make it more aesthetically pleasing, you can perform this kind of masonry wherein you will have uh, a backing structure which can be another stone masonry, and on top of that you can do a plaster work wherein you use brushed flints as the cladding elements, and you would find this kind of this kind of masonry eventually. Now, apart from rubble masonry, we have ashlar masonry. So ashlar is a finely dressed stone, either an individual stone that has been worked until squared, or a structure built from such stones. Ashlar is the finest stone masonry unit, generally rectangular, cuboid, or less frequently trapezoidal. Ashlar masonry is constructed using accurately dressed stone that possess uniform and fine joints. The thickness of the joints ranges about 3 mm, which is arranged in various patterns. So the joints is made to be, very, very small. The gap between each ashlar stone is going to be very small because you want to minimize on that part and want to maximize on the aesthetic that the masonry is giving you. The size of the stone blocks must be in proportion with the thickness of the walls. Ashlar is the various types of ashlar masonry we are going to look at are ashlar fine masonry, ashlar blocking course, chamfered, rough tooled, and rock faced or quarry faced ashlar masonry. So the first one is ashlar fine masonry. Right, in ashlar fine masonry construction, each stone is cut into uniform size and shape, almost rectangular in shape. Okay, so as you can see from the image also, it resembles it's like your block masonry. Block means it can be your fly ash brick, it can be your uh, ASC block also with different colors. So they are, well shaped, and uh, they are providing perfect horizontal and vertical joints with the adjacent stones. In Ashlar fine masonry, an Ashlar fine masonry construction is very costly, mainly because the type of stone that you are acquiring is going to be on a higher quality, and also the amount of energy that you are going to spend on perfecting the shape of your ashlar is also going to be heavy, the amount of energy you're going to use. And also, finally, as they are heavy materials, the amount of energy, the amount of workload that you are going to pay in order to lift this up and construct it, it's going to be costly as well. Ashlar block is very similar to Ashlar fine. It is also a combination of Ashlar masonry and rubble masonry. So consider an Ashlar fine on the facade part, and on the backing part you have a rubble masonry. Then you will have an Ashlar block in course. The face work of the masonry stones is either rough tooled or hammer dressed stones. So that makes the difference. So in Ashlar fine, you always polish it and make it fine. However, in Ashlar block, you have the option of making it fine or making it rough by using, hammer or chisel or any other type of roughening tool. The backing of the wall may be done in rubble masonry. So it's going to be there are going to be two types of masonry in your wall section. So we have an Ashlar chamfer. So a strip is provided as shown in the figure below, but the sides are chamfered or beveled at an angle of 45 degrees by means of a chisel at a depth of 25 mm. So for as chiseling all the block is going to be a bit costly and time consuming or energy consuming, so you would often find this chamfered masonry on the queens, sorry, on the queens means that on the edges of your masonry. Here on the right hand side we can see that ashlar chamfered masonry in combination with your brick masonry over here. So on the left hand side it's another ashlar ashlar masonry that is being that is being taken together by a kuyon made up of ashlar chamfered masonry. You would often find this kind of construction when mainly in exposed brickworks wall or exposed stone masonry walls. So as I had mentioned before, as the corner is the area that is going to take lateral tensions, so it is where you need reinforcements. So this is where the better quality stoneworks, the better quality masonry is required. So Aslar rough tool masonry. This type has stones whose sides are finely chisel dressed. The face of the stones is made rough by means of tools. Around the perimeter of the rough dressed face of each stone, a strip of 25 mm width is provided. So you are providing, a gap in order to emphasize on the pattern that the stonework or the masonry is creating. I might have talked about this in the brickwork, especially in the pointing that we studied. The reason why we are doing pointing is we are emphasizing the pattern that we are creating with the masonry, right? So same goes for this type, even in stone masonries also. You do some kind of a pointing and you can get different types of looks as well. So as you can work with different shapes and sizes of stones, then the variety is more or less it can be in many forms. So here you can also see that we have different sizes of stones, and they are being sandwich, or we can say they are being um, neatly layered on top of each other, and they are given a sufficient amount of strip, especially at the joints. Strip of 25 mm width. 25 mm is very close to an inch. So more or less, when we talk in terms of imperial, we talk of an inch. And when we and look at this, I hope you can see my cursor. All right. So when we talk about stone masonry nowadays, we are talking mainly its application for aesthetics. So most of the time we are seeing stoneworks or stone masonry like this. We try to emphasize on the pleasing visuals that it is giving. So the likes of this, you will see that there are some areas where we have larger blocks, and there are some areas we have smaller blocks. All right. So in the section, in the section I showed before, we are seeing different types of stones that are used there. So these types of stones, the larger stones, are basically that bonding stone or the bone stone that we saw. So these are larger stones which penetrate through your wall and form a good bond between the outer part and the inner part in such a way that there is no vertical crack inside as well. So you do not want those cracks. Even though you are working for the aesthetics alone, then you still have to cater to the dead load that it is carrying. The dead load means the load of the stone, of the masonry in itself, not the external load that it is having. Here we have a rock or quarry face masonry. So In Aslar rough tool masonry, we are finely chiseling the face of the masonry of the stones. Right here, it can be different types. As per the type of the stone that you have, then the finish is going to be slightly different. So in rock or quarry faced, so when you have this type of masonry has a 25 wide strip made by chisel placed around the perimeter of every stone. So likely you would have roughly around an inch gap. The remaining portion of the face is left in the same form as it is received. So as it is received, in the sense here you would say that why is this so fine and why is this a bit rough? So even from the quarry also, because when the mason is working, okay, the mason does not work, the stone mason does not work like the brick mason. The brick mason simply uses the brick as it is, right? But the stone mason, however, works on the stone itself first um, before before laying them. Okay, so here you would have you would have a stone which is already more or less smooth on the face side. So the face stone that is going to be available is already smooth. So the shape, this size, this is where the mason has his or her control. Okay, so when he cuts in the desired shape, in rock or quarry face masonry, he does not do anything on the face part. He just leaves them as it is. So it would have its, that is why it's called a quarry faced or a rock faced. So more or less, it tend to retain the original form where it is brought. All right. Last topic of the day, we have stone thresholds. So stone thresholds are nothing but regular stone slab provided on doorways. All right. So you would have these on your wooden chaukat. I hope by now everyone knows what chaukats are. As chaukats are the door frames, not actually the door frames, the structural members, which would be vertical and horizontal, which carry your door panel or your window panel. Okay. So uh, we often have this threshold even in chaukat as well uh, to hold the vertical part of our door. But more or less, this is not necessary, especially in modern construction and barrier-free construction. Can anyone tell me what a barrier-free construction is or a barrier-free design is? Anyone? All right. A barrier-free construction is, all right. Am I still audible?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
As the name suggests, barrier-free means that there are no barrier. So basically, we think about people with disability. For example, if you are a wheelchair user, then if there are steps everywhere, it would be problematic for you, right? So thresholds like this can be a bit of a problematic. For example, especially for wheelchair users, I believe in this image, this threshold is very minimal, so it won't be quite problematic. But for the likes of visually impaired, maybe can form, it can be the cause of certain stumble. All right. So in order to have a barrier-free design, barrier-free built environment, we want to eliminate such protrusions from the floor. So that is why the thresholds that we talk of in the stone, sorry, in the doorways, which would be the chaukat, we eliminate them and we let for example, here also you can see on the right hand side, you see a door, right? The whole door panel itself is here. It's here. So this doorway will entirely open up, right? And this will be more or less free. Of course, this is not a barrier-free design because you have steps, and these steps form the threshold. Okay, this felt forms the threshold, and the reason why we want to eliminate a wooden threshold that is there on the lower part of your chaukat is because that is going to act as a barrier for the likes of wheelchair users and visually impaired. So, however, wooden thresholds are also playing important roles. Sorry, not wooden, stone thresholds or any thresholds uh, below your below your door is important. Has few functions. They distinguish the space. So, for example, look at this. You have different types of flooring. Here we can clearly see that we have a tiled flooring. It can be a stone tile or it can be ceramic, it can be vitrified. And on the other side here, we are not very sure what type of floor over is here. This can be a large marble flooring, or it can be vinyl, or it can be linoleum also. So when we have, different types of floor for different rooms, thresholds, they act as a division. They act as a division between the two, and they help demarcate your space. And especially if there are level differences, right? If there are level differences, for example, I have I'm playing with some space and I want my living room or my kitchen to be at a higher level than the other. Then when such when such play happens, and by any chance that I am going to go for the same flooring materials, when there are level differences and when there are similar flooring materials, we tend to not be able to differentiate that level difference, and we used to stumble. Okay, we used to we can fall because of the level difference because we misjudge it. So when such area happens, if you still want to use the same type of flooring, the same pattern, the same style, with the use of your threshold, you are being given, or you are being warned, or you are being told that there is a change in something. There is a change in something, so you must be more or less a little bit careful with it. So we often use threshold like this, and sometimes we use it as barriers between different parts of the room also. So it solves the height difference. Sometimes due to the decoration process, the floor tiles and wood boards in the two spaces will be uneven. Gated stones means the threshold has a transitional effect and can be sloped or chamfered to solve the problem. So meaning that you can further chamfer your threshold in such a way that for barrier-free design also it will still act like one. And also solving the closing problem. Here we are talking a little bit uh, about your the plank on your floor. If the craftsmanship of the plank is not good enough, the edges of the plank on floor tiles will not be handled well, and ugliness and quality problems will easily occur. At this time, a finishing stone can play an end, meaning that if you have an edge which is not, let's say, which may be protruding out a bit, and just nailing it down is not solving the problem. So in such cases, we can level it out with the help of thresholds. Level it out in the sense that with threshold on top of it, there will be difference in materials, obviously, but then there will be change in as anyway as that is the edge anyway. So with the change of rooms, and it is going to minimize the visual hindrance that it's creating. So even this kind of thresholds can be used in the likes of washrooms, bathrooms, for example. And later, I believe in architectural design, yeah, eventually by this semester, you may design a house, at least a small building, wherein there has to be a toilet which has a bath or a shower area. So we tend to want to have a dry area and a wet area in our bathroom, right? So the dry area mainly comprises of your wash basin and your WC, water closet, which is basically your commode. Okay, water closet, WC, that means your commode. It can be European type, it can be Indian style, it can be Japanese or any style. So we want that part to be on the dry area mainly because we do not wet the floor as much as we would if we were on the wet area, which is the shower area or the bath area. So if there are no separate demarcation, or if we want the floor to be not too, like if we are not having any kind of, let's say, shower curtains or separation between the shower area and your dry area, then in such areas we do not want to spill the wet area. We do not want to spill the water from the wet area to the dry area. So in such cases we can have thresholds as well, but these thresholds will now be a lot more higher than your threshold, your average threshold that you find beneath your door. So this can be somewhere around 100 mm, or 10 centimeter high, or it can be 75 centimeter, somewhere roughly between above 3 centimeter, sorry, 3 inches is going to be useful. But here, as we can see, it is definitely not 3 inch, it would be roughly around maximum an inch. So these thresholds in the interior, it can be a small tile or a granite slab or a marble slab above your already existing flooring. And on your entry, it can be the uppermost part of your steps. Okay, the uppermost part of your steps, which is basically your approach to the plinth. I hope everyone remembers what plinths are, as from the very first day we were talking about different types of different components of a building. We were talking about plinths, right? So plinths make up the base of your ground floor, and it mainly talks about its height of the floor, the height of the floor with respect to the adjacent ground. Here on this particular image, we can see that the plinth is quite, considering that the image that we are seeing here is your footpath or your road, this one, and then it's barely a one step high plinth level, then that means that more or less this plinth is roughly around 4 inch or maximum 5 inch above the ground. So I believe that in this area you do not have much flooding or any of such heavy rainfall. So anyway, this is the plinth, and also this makes your threshold as well. This, I believe, is the carpet above it. So that makes your threshold. And also thresholds can be, if you have stone masonry, if you have a masonry steps, right? These are your steps, and the tile like this, and the tile that you are providing, if it is stone, all right, that can be your threshold as well, meaning that it helps you transition from one space. For example, in this, that space is this road, right? This road is one space, and the interior of this building is another space. So this area is your threshold, and if you are using stone, then that is a stone threshold. All right. So in the English language, when we talk about thresholds, we have other, we can mean other thing also. That is like, the limit, like the boundary. So what is the thresholds? We talk about the limit and the boundary. So basically, even in building construction or in building materials, when we talk about thresholds, it demarcates a certain boundary. It demarcates a certain area. All right. So that is the end of our class for today. Any question?
No, sir.
All right then. Okay. I want you to use your time. Next class you are going to have in, all right, 1.5 hours. 1 hours later, you're going to have a class, and I believe that is going to be the end of today's class. And after that, time to gear up for your submission. And for your second portfolio in graphics, so whatever we have done so far, as well as the other one, and as well as the next chapter we will do next week. All right, please note down that your second portfolio submission for graphics is going to be on the 22nd. All right, on the 22nd. On the 19th, we will be finishing the next chapter. So you will have roughly 3 more days to do assignments from that particular class. So whatever pent up works that you have, please complete it by this weekend at least, and then you will use up this. Anyway, the assignment is not going to be that much, but still with the other subjects, I believe that it will come. And also in BCM, I will be giving you other drafting assignments uh, to be submitted later on. Okay. Another reminder that on the 27th, we are going to have, yeah, 27th, we are going to have test on BCM. Next week, on the 20th, I believe there won't be class on the day. However, I may be able to take it in the night. All right, please put that in mind. 19 will have class on graphics. 20 there will not be any class on the day. However, if possible, I will try to take it in the night itself. And on the 26th, that is Republic Day, we won't have class. By then, graphics will be done. And on the 27th, we will have a test. All right, so that means that by next week 20th or 19th, if I can, I may have to take classes at night. During this time, there may be nighttime classes. All right, please bear in mind, we may have to skip few of the day classes, especially on 20th, it's going to be skipped. Even on 19th also, maybe we may have to take night classes. So please gear up for that. All right, thank you, class.
Thank you, sir.
Thank
Thank
you.
you,
Thank you,
sir.
sir.
Thank you, sir.